Oh, yeah.
Thanks, Pete and Jess, for having me along anyway. And thanks, everyone, for turning up to watch this talk. So it's going to be, it's not exactly going to be a deep dive talk today. It's going to be basically me sharing a couple of experiments I've done with machine learning. So it's a bit like a level 200 talk. So it's not a deep dive. It's not an introduction. We are going to look at some code, but I've tried to keep the scenarios I've looked at fairly interesting with cartoon characters and Christmas trees. So we'll see how we get on. So if you ever wanted to get into machine learning, this is probably a good place to start. Okay, a little bit about me. So I'm the developer relations lead over at Avanade. Avanade are a global IT consultancy specializing in the Microsoft stack. We were actually formed by Microsoft and Accenture 20 years ago, and there's 40,000 of us around the world, but you may not have heard of us, but we're doing some great things. As Pete said, I'm a Microsoft MVP in developer technologies, and I have been for the last 2 years. I do things like create websites for the people in the community, such as the ones listed there, so visualstudiotips.co.uk, and most recently one called techcommunitycalendar.com. I've also written a book on augmented reality. So that might be where the confusion crept in. So if you look for some light reading or some bedtime reading, or if you're a .NET developer wanting to get into augmented reality on iOS devices, you can go get my book from Amazon if you choose, or I can come back and give a talk about it if Pete lets me. Okay, so a quick one about Avanade. I won't talk about them to death, but there's some great things going on at Avanade. We're an international organization. We do some great stuff, great community. We're a founding member of the Green Software Foundation. We've got about 40 Microsoft MVPs working for us. So if you do want to speak to me afterwards or sometime about openings at Avanade, please do. I'd be happy to speak to you. Okay, so this talk, the main event now, is very much a talk of two halves. So the first half, we're going to look at how we create a machine learning model. In particular, these are both going to be image classification models. So we're going to see how we can use C# and do it locally using ML.NET. So completely locally, not using the cloud. And then the second half of the talk, we're going to just switch it up a bit and do everything online and train the model online and consume it from online as well. So two different approaches there. And you'll see the pros and cons of both approaches, but we'll start with the local one first. But first, I thought I'd share with you my motivation for wanting to learn machine learning. So some of you might remember a few years back, Microsoft started putting some websites out there, a bit like these two on the right-hand side, like whatdog.net. And the idea was you could upload an image of a dog, and it would use this very, very fancy machine learning image classification model, and it would tell you what breed you were, sorry, what breed the dog was. But then people started uploading images of themselves, and it would say what breed of dog that you look like. So it's became quite interesting. And another one was you could upload an image of yourself or someone else, and it would use machine learning, artificial intelligence, and image classification to roughly tell you your age. And it always aged me a bit on the higher side, so I don't have great memories of that site. But back a few years ago, these were quite cutting edge. A lot of machine learning we take for granted these days. Back then, it was like, wow, how does it know that's a Cocker Spaniel? How does it know I was said my age then. How does it know I'm 25 years old? I'm not. But see, I was very much inspired by these. So I thought to myself, I want to learn how to do this. But I'm a .NET developer by trade. I want to try and use C#. I don't want to use Python. And to start off, I want to see if I want to do it locally and not in the cloud. So I found Microsoft's ML.NET. So that's what I'm going to show you how to use to start off with, or I explain the experiment I did with it. I'll just also say at this time that I'm not a machine learning, AI, or data science expert. That will become very apparent soon. I'm just sharing an experiment that I did, and hopefully encourage you to do an experiment yourself. So we're going to be using something called transfer learning, which is this one over on the right-hand side. And what that means is we're not building like an image classification model from scratch. We're actually building it on top of an existing one. So we're taking an existing image classification machine learning model, and I'm training it with a few images to sort of specialize it in my use case. And then I've got that comes out the other side of that is this image classification model that I can then use and consume. So let's go back to, I think it was last summer when I wanted to get into ML.NET. So I started Googling around and see what C# code I could play around with to try it out. And the first example I found was a bit boring, if I'm honest. It didn't sort of thrill me. It was, how do you identify cracks in sort of grayscale images? And I thought, that is just boring. Don't get me wrong, it's probably a really important use case, especially if you're sort of applying concrete to a nuclear power plant or something like that. But for me, if I want to learn something, it's got to be interesting to me. So I thought, well, what can I apply this same sort of approach to make it more interesting? The code was sound. I just wanted a bit more of an interesting use case. So then I thought, well, what can I do that's really, really simple, something that's really easily categorizable, and very sort of polarizing. And I don't know why, but I started thinking about cartoon characters and how cartoon characters are, generally speaking, good cartoon characters or baddies. They're either good guys or bad guys. So I thought, well, what if I got a load of images of goodies and a load of images of baddies, trained an image classification model, and then give it some other images that weren't in the training data and see if it would kind of be able to guess if it was a goodie or a baddie. And at this point, I had no idea if this was even possible. I knew it was possible with cracks in tiles, but I didn't know it was possible with cartoon characters. So I thought I would give that a go. So then I started thinking, well, why do I think sort of think some of these are goodies and some of these baddies? What personality traits can I see in those images that make me think they're goody, they're baddies? It kind of really made me think about how our brain works and how it infers images, and in particular faces. Is it sort of yellow eyes? Is it the sharp teeth? You know, obviously an image classification model doesn't really see sharp teeth or eyes. It just sees pixels and collections of pixels, and it's doing something very clever under the hood. But it did get me thinking as what my brain's doing when I'm looking at faces and figuring out things. So then I kind of went off at a tangent and did a completely different talk about how we analyze faces with and without code. And I'd love to come back and give that talk, but just really briefly about this talk. It's fascinating. So our brains have this built-in ability to detect faces in our environment. And it's why, if we look at some everyday objects, we can instantly see faces in them. It's because our brain is constantly scanning our environment for faces. And not only can we see faces in inanimate objects like these ones on the left-hand side, and we can see images in handbags and peppers and typewriters and mops. So not only can we see the faces, but we can also almost attribute a mood or personality to these faces. And all we're seeing is a few lines. It's absolutely fascinating. And this is called, I think, pareidolia. I don't know if I've said that right. It sounds like a plant, pareidolia, but that's apparently this phenomenon that we see faces in everyday objects. And apparently back in sort of early man and woman, it was very important in our survival, being able to recognize faces. You know, is that person over there holding a stick in the hand or a sword or some sharp tool? Are they someone I recognize, or are they not someone I recognize? Is it friend or foe? So it's very important to survival back then. Fast forward about 2,000, 3,000 years, it's more important in our success than survival. You could argue it's the same thing, but these days, nonverbal communication accounts for sort of 70% of human communication, and being able to read someone's face allows us to empathize with them. So it's very, very important. And sorry, a bit of a tangent, but it did really get me thinking about how our brain looks at faces and infer things. But back to the main event, we're looking at goodies and baddies and training an image classification model. Sorry for the tangent. Right, so step one, I thought I need to get images first of all. So I just Googled good cartoon characters and bad cartoon characters, and I got 70 images of good and 70 images of bad cartoon characters. And that took a while in itself. But I thought with 140 images, surely that's enough to get started creating this image classification model. Just a word of advice at this point: when you do train your model, you need to, and you come to test that model, you need to make sure you're not testing with images that you actually use to train the model. So you have to keep some aside. So yeah, don't use test data in the training data. And then just a quick word on bias. When I was downloading these images for Google, I did stop and think to myself, I know I'm not a data science expert, but I do understand that bias is a problem in sort of all sorts of data science. And it did make me think, well, what if I'm subconsciously downloading more good female characters, or whenever my eyes go into red cartoon characters and I'm attributing them to bad cartoon characters. So it did really make me think about what kind of bias is going on in my brain. And but then I had to stop and have a word with myself and think, well, this is just an experiment. This isn't production data. This isn't going to be used for anything important. So I just decided to give myself a break. But if you do ever sort of create these image classification models or any sort of machine learning models, you've got to think about what bias is going into those, the data set. And I guess if I did want to remove the bias, I could maybe randomly get it to download images without me manually creating them. But this was just an experiment, like I said. Yeah, garbage in, garbage out is the old adage, as they say in machine learning circles, I'm told. Then step 2, I had my 2 pots of images. I've got my C# code example from my tile use case study. So I pointed at the 2 sets of data, ran the code, and it didn't work. And then I found my first gotcha was, if you're using ResNet to train your image model, the images need to be 224 by 224 pixels. Now, ResNet is this image classification, machine learning model that I'm building on top of, this is where this transfer learning comes into place. And so then I had to go and resize all these images to make sure they're all 224 by 224. And that was quite difficult because not all the images were squares to begin with. So I had to go ahead and crop them and sort of get the faces in shot. So that took an absolute age, resizing 140 different images. But I did. Then I ran the code again and it didn't work. So then I thought, well, what is going on here? And I noticed that the cracks in tiles use case scenario, code example, had lots and lots of images, more than 140. So out of desperation, I just selected all my images, all 140 of them, or however many I was using to train the data, copied and pasted them. And then instead of having 140, I had 280. Yes, I had 2 of every image. And I imagine is there any data scientists on this call is probably holding their hands in their head in their hands thinking, what on earth have you done? You've just duplicated all your data. Yes, that's I did, but I was in a bad place trying to get this to work. But it did actually run after I reran it. So it works out. It turns out there's some sort of minimal threshold needed on the minimal number of images before it will actually let you create an image classification model. And it's somewhere between 140 and 280. I have no idea where. But yeah, never gotcha. So then I did run it and it worked this time. It produced the model. And then when I pointed that model and the code at 6 images that I didn't have in the training data, so this was my test data, for the 3 bad guys and the 3 good guys, it detected with 100% accuracy that Cruella de Vil and the evil scientist and whoever the robot skeleton is with the blue hood, it detected that they were all baddies, and it detected that Super Ted, Banana Man, and He-Man were all goodies. And I was quite impressed at this point, and I assumed I had something wrong in my code, as you do when it works. Not first time, but when something works and you were expecting it to work, you kind of look for where you've done something wrong. But I hadn't done something wrong. I actually managed to create an image classification model that would determine if a cartoon character was good or bad. So if you ever do this, and I do recommend you go and grab my code from GitHub and try this out for yourselves or on some other sort of use case, it's a bit weird that at that point where you've got this image classification model working, you kind of produce this, not artificial intelligence, but this black box that you're giving images to it. It's doing something under the hood. You're not you've not written that code yourself. It's like a deep learning model, and then it's spitting out the answer at the end, and that answer is accurate. It's a bit scary, to be honest, but I recommend you do it just to get that feeling. So I now had a console application that would use this model that I created, and it would take an image, tell me if it's a goodie or a baddie. But I didn't stop there. What I decided to do was upload it into an Azure function so that I could just upload an image to that Azure function. It would run it through the model, send it out the other end, and return back the request and say, this is a good guy or this is a bad guy. So I started doing that locally. And then the first gotcha I had when creating an Azure function locally, if you've not done it before, which I hadn't, was that you need to add this cause item into the app set local settings JSON, otherwise it won't work. And then when you upload the Azure function, well, once you've got it running locally, and you're using something like Postman to call it, once you've done that and you've uploaded your Azure function up into Azure, because you've got it live and you want to test it in live, you need to go to the cause section and see which origins are allowed to send data to it as well. So a couple of gotchas there, if you ever try and do this yourself. So then I had an Azure function which I could call with Postman, and that was working. But then I thought, well, I don't want to stop there. I want to create a bit of a website. I've got a bit of a bad habit of buying domain names. So I'd already registered goodyorbaddy.com because I knew I was going to host it at that and have this experiment running there. But I didn't want to create a fully blown .NET Core web application. I don't know React or anything like that. So I thought, well, surely I just need a standalone HTML file. I just host it somewhere. I just upload the image to that. That sends the image to my Azure function. The Azure function sends the request back, and then my simple HTML file will just show the results. So I didn't actually need a full site. So what I did instead was just host an HTML file that did all this on GitHub pages, and then pointed the goodyorbaddy.com DNS to point to GitHub pages. And I'd never used GitHub pages before, so it seems like a very good way of just hosting a very, very simple website if you don't want any complicated stuff going on in the back end. Another tip is that I discovered a nice extension called Live Server for VS Code, so that when you hit go live, I think it is, it'll actually spin up a local server, and then you can just hit that HTML file like you would, it would be running live. That's quite cool. Another thing that I wanted to use was I wanted the ability to just drop the image onto the page and then it send it up to the Azure function rather than hitting browse, find the file, or hit upload. A bit lazy, I know, one step instead of three, but I found a JavaScript library called Dropzone, which did just the trick. And I'll show you that soon. So yeah, this is the end result, goodyorbaddy.com. That's just Dropzone on the left. So if I go over to goodyorbaddy now, if you bear with me, that's the next talk. We'll talk about Christmas trees. So if I drag it an image, it's a little bit on the slow side. So let's give it this one. I forget what cartoon he's from, actually. It's going to bother me now. What's he from? Someone will know. Someone will put in the chat which cartoon character is from. So that's going off and going to the Azure function. Hopefully, if it's not failed, it'll come back and say if it's a goodie or a baddie. If it's a bit slow, this is going to time now. No, it's a baddie. It might be a bit slow because the Azure function I've created is not one of these durable ones. It kind of probably has to, and I'd not warmed it up before the talk, so it's probably spinning it up all at the same time, the request. So yeah, detected that was a baddie. Let's give it some more. Let's give it Shaggy from Scooby-Doo. Surely he's a goodie. You also notice that it's binary. It's either saying goodie or baddie. The code samples that I was seeing didn't show like a degree of confidence or probability. Yeah, that's a good word. A probability that it's like 55% good or 45% good. But in the next talk where we use the cloud, you do get that. So that's one of the differences. But that's the site. You can actually pull that code down from GitHub and run this locally and try this and train your own models if you like. So this is the eventual architecture I ended up with. So I did describe it, but there you go again. DNS points to GitHub Pages. GitHub Pages sends the file to Azure. Azure function holds the machine learning image classification model that we trained locally with images and that was uploaded there. Now, the image classification model did end up being very large. I don't think that's to do with the number of images that I given it. I think it's to do that it's using this ResNet under the hood. Actually ended up being 160 megabytes zip file. So just be warned that they can get quite big. I imagine there's different ways of shrinking that down. In fact, I don't think you're really supposed to have an Azure function that's that big. I think it's supposed to be quite lightweight. The first few times I tried uploading that code that's 160 megabytes to Azure, to an Azure function, it failed the first 2 times, but it eventually wanted to work. And then someone, I did this demo internally at Avanade as a bit of a brown bag session, and someone said to me, "That's great, but what if the cartoon character started off as a good guy, but then halfway through the film turned into a bad guy?" And that I kind of had to scratch my head and take a deep breath at that point and not really show how sort of slightly frustrated I was at that talk, because obviously I can't create an image classification model that takes an image and understands the sort of the plot, the underlying plot of a cartoon character and what's going on in that entire film. But I did humor him, and I took an image of a cartoon character that started off good, and a bit of a spoiler coming. If you've never seen Frozen, like me, 1,000 times, then there's a bit of a spoiler coming. So just put your hands over your ears, and we'll move on quickly. But there's a cartoon character that starts off good, and then he ends up being evil. So I uploaded an image of him when he was good, and it said he was a goodie, and an image of him when he was bad, and it said he was a baddie. So I was quite happy with that sort of. They've been able to check, take the same cartoon character and infer that they were good or bad at a particular time. So that's goodie or baddie. It did also get me thinking about what other possibilities there are for machine learning. You could train it on all sorts, and these things are great for hackathons or side projects. You could train them on biscuits. You could train it to recognize different types of biscuits. I don't know how useful that would be, maybe in the Vittis factory or something, I don't know, but you could get it so if you upload an image of a digestive or a hobnob, it would be able to tell you which one's what. Or you could do with flags. You could have lots of different images of flags, and then whenever you give an image of a flag, it would say what country it's from. You just got to use your imagination, really. Another one I had was a bit of a play on words. What the duck, XYZ. There's another domain I registered. I don't know why. I've not used it yet. I've got a problem, seriously. And what I wanted to do is, I don't know why ducks, but take images of different species of duck and then train it, and then give it different images of ducks. They'll say what species of duck that was, and maybe take that to the RSPB and say, "Hey, would this be useful? I don't know. Here's the thing I did." But yeah, what the duck, that's another one to do. And that kind of concludes part 1 of the talk. We're going to go look at the code for goodie or baddie. But before we do that, I'll just say, scratch an itch. This is all I've done with it. So I don't really use machine learning in my day job, but I was interested in it. So go scratch an itch. Keep it simple as well to start off with. It doesn't have to be trying to forecast, financial stocks or anything. Just keep it simple, keep it silly, keep it fun, and then come back and share what have you learned, because not only will you help others like I'm trying to do here, but also help you understand it more as well. Yeah, it's open source on GitHub. Let's go and jump over and look at the code for goodyourbaddie.com. And you're going to really tell that I'm not a data science or machine learning expert, because there's going to be parts of this code that I'm just going to really gloss over and say, go and look up the docs, because it can be a bit complicated, but we'll give it a go. So the first thing you'll need to do if you do pull down this code, my code from GitHub, is you'll need to create the model, because I didn't upload the 160 megabyte zip file. I'm led to believe you can upload files of that size with GitHub, GitLB, a certain tool that allows you to upload large files. I couldn't get it working. So I just thought, I'll just make them train the model locally. That'll get around that and make them do the work and actually learn at the same time. So you'll need to uncomment that and actually train the model. And this took 7 minutes and 30 seconds on my laptop, by the way. You might wonder why I mentioned that. Well, we use that as a bit of a benchmark for part 2 when we do it in the cloud. So if we go to the create model, I got a path to my training folder where the images are kept. I'm instantiating this ML context, which is really the meat and potatoes of ML.NET. Then you're going to really, my voice is going to go higher as I kind of get more unsure. Then you get the images from the directory, and you're saying use folder names as labels. So in that training folder, I'll have a folder called Baddy or Bad, and a folder called Goody or Good, and it's going to use those as labels. And by labels, I mean that's what we're going to label those images as, bad or good, right? So it gets the images, then it loads from a numeral, so it's doing something to those images to create it into image data view. Then it shuffles them. The clue's probably in that method called shuffle rows. You get your shuffled data. Then it's creating some sort of processing pipeline where it's doing some mapping of the labels to the bytes. Again, not 100% sure what's going on under the hood, but try it for yourself. Maybe look into it more. We're creating this this pipeline. We're splitting some training and testing data, doing some validation test data. Again, I'm not 100% sure what's going on under here. Then we're creating some options. We're saying to use this ResNet deep learning image class, machine learning thing under the hood. Sorry, my words are failing me at the moment. And then we're saying this is just like a delegate that says, as you're going through the training, just output to the console what you're doing. And then at this point, getting close to the end of this method now, thankfully, we've got this pipeline, and then this is doing the work. It's actually creating the model here, this fit method. It's using the pipeline and the data, and it's saying create the model, basically. And at this point, we have it in memory. So we could keep that in memory and use it to actually test different images. But actually what I want to do is save it to disk. So this is where I'm saving that model to disk using this train model path that was at the top, I think. Yep, that one there. Then once you've done that, and it'll take 7.5 minutes, you'll have your model trained. You can then run these methods, and this is using that model and applying them to sort of test data. So this method, I'm passing in the path to the test image, the path to the trained image classification model, and then what I'm expecting it to say, the result to be. So let's go look at that method. Again, we're instantiating the ML context. And again, if you do use ML.NET and you're a lot more familiar with it, very apologize for my code. It's probably very inefficient, but it was just for demonstration purposes. So I'm loading that model, giving it the path to the model, creating a prediction engine, apparently, and it's just kind of mapping the inputs to the outputs. I'm saying what my input is, I'm saying what the expected label is, the path to the image. I'm even getting the bytes of the image that I want to test. And then it creates a prediction as the output, and I'm outputting what the result was. So it's saying image path or name, the expected value was blah, but the actual value was blah. And that's what gives us the console output. So I'm going to test the demo gods and actually run that, see what happens.
Given this evening, that's very brave.
Well, I'm in a bit of a brave mood, but I can't actually play because it's underneath. Here we go. It was underneath my Zoom thing at the top. Don't worry. It doesn't take 7 minutes and a half to actually run the test. But after this, we'll go to the second part of the talk and look at how we can do this in the cloud, but this time with Christmas trees. Oh, here we go.
Just while you're doing that and waiting for that to spin up, Alan Buxley asked a little bit, can you explain or describe how it decided what's a goodie and what's a baddie, and explain any bias? I'm not quite sure.
Yeah. So So yes and no. So I can't fully explain because when you create these machine learning models, they're effectively like a black box. It's full of maths and weighted paths that it kind of calculates based on what you've given it and you've trained it on. You're saying, if I give it this input data, I'm expecting this output data. And it uses those two things to produce, I believe, a lot of sort of weighted paths and maths. So I can't fully describe how it works under the hood, if that makes sense. Yeah, it is a bit of a weird feeling because as developers, we're used to understanding every line of code that goes into the algorithm as to why something happens the way it happens. I find with machine learning, I almost have to trust that if you're getting the right results at the end, and you're quite happy you've trained it well, you almost have to walk away not knowing how exactly you're working under the hood. Is my experience, very limited experience in what I've tested. So there we go. We've got it taking the images and the expected value was bad, and it said bad, and it did that all 6 times. So that was Goody or Baddy. Were there any other questions, Pete, before we move on to the cloud part of the talk?
No, because I let a few people in and disabled the chat just in case. It's re-enabled now, so if you've got questions. Alan did follow up there asking, it's more about his concern about it being accidentally racist, which, we're looking at you, Twitter. But
yeah, well, yeah, it's only as good as the trainers and the data. So this is what I was talking about earlier, that I don't trust myself that I've trained this properly because I was manually curating the images to go into the training data. As I was just saying, oh, there's Winnie the Pooh, he's a goodie. There's a Baddy, he's Darth Vader. But I could be choosing more males and females. I could be jumping over certain things. So because I was manually picking these images, I've got unconscious biases happening all the time. We all do, and we have to realize that. So what if I was to do this in production? I don't know why I would need to create this in production, maybe for Disney or something, but you'd have to randomize the data going in or do something to take bias out of the equation, or at least reduce the bias from the equation.
And then in 20 years' time, when they reboot it, it turns out all of your expectations about who was a baddie and who was a goodie is wrong anyway. Looking at you, Karate Kid.
Yeah, absolutely, yeah. But it's very clever at point in time stuff, I find. So that concludes the first part of the talk, where I've trained it locally. I've not used the cloud other than to host the model and the website and the Azure function. Next part, I'm going to look at something that I did in November, December this year. I kind of, on a similar thought, I thought, what if I could, a lot of my experiments start with what if, asking to myself, I thought, could I create an image classification model that could discern between Christmas trees and regular trees? So just to clarify, my definition of a Christmas tree is one that's got decorations and lights. If it's not got a decoration and lights, it's a regular tree. If it's got decoration and lights, it's a Christmas tree. I also wanted to try learning this tool here called customvision.ai, this website. So it was a good kind of use case for that. So let's go jump over to that. And I think it's this side. Here we go. So what we're going to do is we're actually going to build this model that discerns between Christmas trees and regular trees. Then we're going to, this site actually hosts it. Then we're going to call it in Postman, this endpoint. And then I'm going to show you the code of this working on ischristmastree.com. I'll jump to the end. So very similar site to goodyorbaddy.com. Is Christmas tree here, and you can upload an image of a Christmas tree or anything really, and it will tell you if it thinks it's a Christmas tree or a regular tree. But let's create the model first. Let's not jump to the end. So this is a model I created earlier and the one that site's pointed to. But I'm going to show you the steps to create it from scratch. Okay. So if you go to Custom Vision AI and log in with like a Microsoft account of yours, you won't have any projects. So go and hit new project, give it a name, and we'll call it Christmas Tree is Christmas Tree 2. You don't need a description. You need to give it a resource. And at this point, I think you just Yeah, that's one I've already created. You'll need to choose just a Visual Studio subscription. Sorry, and it's an Azure subscription. Sorry, I beg your pardon. Azure subscription. And then you'll choose cognitive services, choose location, and the pricing tier, S0. This, I've never received a bill for this. So I imagine we're talking fractions of pence for every invocation. So I wouldn't worry too much about incurring a cost when you're experimenting with this sort of stuff. So then I choose my resource, the project type. I'm choosing classification. I'm not interested in detecting objects in that image. I just want to determine if that image, the whole image, is Christmas tree or regular tree. So that whole image will be classified as one thing or another. I'm going to be using a single tag per image, and the tags will be Christmas tree or regular Christmas tree or regular tree. And then the domains, well, this again is this transfer learning. I can choose pre-existing machine learning models dependent on my use case. So if I'm doing something that's very heavily landmark related or food related, I can go ahead and choose one of these. For the purposes of this, I chose a general compact S1. Why this one? Because I tried it and it worked. I also led to believe because it's got this compact one, it's a good one to choose for if you're going to package that model along with an iPhone app or an Android app. So I imagine that's coming in a lot smaller than 160 megabytes. And once you've created these models, as well as being able to hit the endpoints for them, you can actually download the model in different formats and use them as well locally, but we're not going to do that today. So yeah, general compact S1, and then I've left it as basic platforms here. I don't know what this Vision AI dev kit is, so I'm definitely not choosing that. That will create my project. Then the fun comes of adding the images. And I've got 3 different folders of images. I have got 20 images of Christmas trees, 20 images of regular trees. Remember, no decorations, no lights. And then I've got some test images, which remember aren't in the training data, shouldn't be in the training data, because you don't want your model to have any knowledge of these images you're going to be using it to test it on. The other thing I'll mention is I thought I'd make my life a bit more difficult, and having some Christmas-shaped trees actually in here. So we've got some fir trees that are very shaped like a Christmas tree, but they're not Christmas trees because they don't have lights or decorations. So I'm going to upload my regular trees. And I give it a tag, and I'll just call it regular tree. And I hit upload, and it uploads them really quickly. I don't know how it does it, but that was done. 20 images quick. And then I want more images, so I'm going to add my Christmas trees this time. Call it Christmas tree. Again, different shapes and size Christmas trees. Some close up, some far away, some inside, some outside. Upload 20 images. And also remember, in our previous example, we used 70 in each data set. We had 140 images. We're only using 20 at this time, 40 in total. So we'll see how we get on. And then we've got our 2 sets of images, Christmas tree and regular tree. So next thing I want to do is hit train. We can do quick training or advanced training. I've never used advanced training. I don't know if that will give me a better results with more productionized version of the model, but I've always used quick training and then hit train. And that takes about, I think, 4 minutes on that sort of number of images. And you probably guessed at this point, we're not going to sit and chat for 4 minutes. We're going to jump back and look at our model that I've already created. So once it's trained, you'll get a screen that looks like this, basically telling you what it'll actually do is it'll take those 20 images and it will take a few aside and not use them in the model and use that to test the model it creates. So it's saying, based on the 20 images you gave it, 40 images you gave us. Yeah. We've been able to create a model with 100% precision and recall, which sounds great, doesn't it? It also says, yeah, both the sets of data looks good. And we've got red here because it says, you've only got 20 images in each set. You really want at least 50 in each. So you've got 40, you really want about 100. But I know this works. So we'll ignore that friendly warning there. Then once you've got your thing trained, before we publish it, you can do quick test. So you can either, and this is actually testing that model you've created in the cloud. So we can give it a URL of an image, or what I actually prefer to upload images from my local machine. So let's go to our test folder. And remember, none of these are in the training data. So it shouldn't know about what these are. Yet we're going to see if it can decide if it's a Christmas tree or not. So let's start with something simple. I think we can all agree, and I'll zoom in a bit because I realize my resolution might a little cause squinting. Here we go. We have got our first one. It is saying it's 94.8% sure it's a Christmas tree. It's pretty good. Try some other ones. Here's a white one. This one's saying 92% Christmas tree. This is good. Let's try a close-up. It's a bit blurry, but it says it's 91% sure it's Christmas tree. Let's try some that aren't a Christmas tree. That one's quite obviously not a Christmas tree. 98% sure it's a regular tree. Just bear in mind whichever it thinks gives the higher probability to appears first in this list, and that's important when we can look at the JSON later. Here's one that's not a traditional shaped Christmas tree, but it still says 93% sure it's a Christmas tree. I won't go for all of these, but let's try and trick it. So there's an upside down Christmas tree. It's still saying 99% sure that's a Christmas tree. And let's try some more. Here's one where the tree's wrapped in toilet paper, still saying 96% Christmas tree. Don't forget, we've only trained it on 20 images for Christmas trees, so it's quite scary what the results we're getting back. Here's one in a Christmas tree costume. I'd still count that as a Christmas tree. It's got decorations. So yeah, it's a little bit unsure this time, but it's still still thinks it's a Christmas tree. Let's really try and mess with it. Let's give it this one here, which is a giant dinosaur or Godzilla-shaped Christmas tree. It's got lights on, so it's a Christmas tree, I'm afraid. 95% sure it's a Christmas tree. I don't know how it does it. Magic, black box, maths, voodoo, who knows? So now we've got, let's do one or two more. Let's do this one that's the shape of a Christmas tree, but it's still saying 99% sure it's a regular tree. So I'm quite happy with the model. In fact, I'm actually thrilled, ecstatic with that, the results of that model, considering how few images we gave it. So then this would say publish. So to hit publish, it would be published, and you get this prediction URL, which means you can now hit this endpoint and get results back. So we can either send an image URL to this endpoint, or we can send an image file to this endpoint. So this is what we're going to do next. We'll also need to send across in the headers this prediction key and this content type, and then set the body to the image file. So let's jump on over to Postman, hopefully, which I have got the URL in previously. And I've got my headers in, my prediction key and my content type. But tell you what, let's clear the image that I was using. Let's choose an image for ourselves, one that I've not done yet, but this one here. So this is like an upside down Christmas tree. It's really in a really messy room. It's just rubbish Christmas tree, but it is a Christmas tree. So then if I go off and send that to the endpoint, you'll notice it's also a lot quicker. That's back already, 1.5 seconds. So that's already a lot quicker than the local model we were hosting in the Azure function. Could be various reasons for that, right? But it's faster for this demo. It's saying it's 82% sure effectively that it's a Christmas tree. which is great. So my endpoint works. So then what I'm going to do is show you the code to consume it in a website.
Kevin's asked a question in the chat. Is there a way to do batch testing? Sorry if you've answered that.
I imagine this has got an API. So I would say yes. I don't know. I've never used it, but this sort of tooling usually has got. What do you mean? Do you mean batch testing? Just batch testing an existing model? Then I guess you could just do a loop, couldn't you? Or a curl script or anything that just takes the endpoint.
You can unmute yourself again now. I've given everybody the privilege to do that again now. So use it wisely. So if you wanted to come in on that, Kevin, by all means do.
Sure. Yeah. If you can hear me still.
Yep. All good.
Yeah. Lee, I was just curious, like for like a batch inference to either pass a list of URLs to have it test, or I was actually curious during the custom vision, you had that single link where you could test a single file. I assume they don't give you an option to say upload 4 files and try and test it just to get like a performance. That's probably an after thing after you've deployed the model.
Sure, I don't know, but I've not looked at the. I was going to see if it was had some swagger on the endpoint to see if I could get all the different methods. I think I'm right in saying there's more than two. There's more than just those 2 methods that you can send it. I think I won't Google now, but I'd be also interested to know what other methods there are just from single predictions.
Okay. Yeah. No. That makes sense. You're probably right. There's probably one there. I was just curious as far as what you could pass it.
Yeah, even if there isn't, you can. I'm sure you could just put it in a loop, right?
Right. Yeah, that makes sense.
Okay. Oh yeah, I also forgot to mention that I'm so glad no one's uploaded any naughty images. It records every image that's been uploaded to the endpoint, and then with the result as well. Yeah. Okay, so I was just going to show you the code of consuming that endpoint. This time I've done it slightly different. It's just an HTML file, very similar, somewhat similar to the Goody or Baddy, but this time I'm not using drop zone, so it's a good old-fashioned upload button. Where is it? Sure, I'll just run it locally, see if that works. I'm tempting the demo gods today, as you said, Pete. So this is that live server button extension for VS Code, so I do recommend it. That's just spun that local server really quickly. So all this does is allows you to choose file and upload it. I won't do that because I don't think I just don't want to do it right now. So this file here, when you've, let me just go to the bit where actually you're choosing a file. Here we go. On change equals open file event. Some of this code is ripped off from the internet as well, so might not be production code. Okay, so then what's that doing? This just chunks that file into, it's hiding some panels, chunks the file into bytes, creates a blob, and then Ajaxes that up to that endpoint we were talking about earlier, adds some headers to that request, fades out some panels, posts it up, says what the data is, and then when it comes back, it's saying, get me the 2 different predictions. And remember, these can be in different orders depending if it's a regular tree or Christmas tree, and get me the probabilities and the names. And it's saying if the probability is greater than 50% that it's a Christmas tree, then show it to Christmas tree panel, else show it to regular tree. So it's pretty simple code. It's not doing anything too complex there. So that is the Christmas tree. I think that's all I had, Pete. So that ended very abruptly, didn't it? Sorry, Pete. I thought I had some more slides, but I don't.
Well, you can just ad lib for another half an hour.
Yeah, I mean, let's see the live site work just to show it's not just smokes and mirrors.
It was really good, by the way. Thank you very much.
Thank you. There we go. Yes, there you go. It's a Christmas tree, and it's 95% sure it's Christmas tree. And the code, if you want to look at some bad code, is on my GitHub for both the Goody or Baddy is Christmas tree. So, Sure. And hopefully, just to wrap up, Pete, that is, if you've never played around with machine learning, that gives a good example of how easy it is to get started with image classification, machine learning with .NET and Azure. That's kind of the whole point of the talk.
Oh, very good. Did anybody have any questions? You should. Let me have a look. Oh yeah. Now you can unmute yourselves again. That would help. And also, yeah, should be able to turn your webcams on and all of that.
Lee, a question again for your project. Is there a limit to how many images or how big of a project you can create?
Oh, I don't know. I've really not pushed this through its paces.
Right.
For this latter project, I don't know.
Okay. I was gonna say, if I was to upload, like 10,000, cat dog images, is it gonna crash it, or is it got some sort of a limitation? I saw like a 4 meg per picture limit, but it didn't seem like there was any limitation around how big of a project we can work with, or how big of a model it'll make.
It's a really good question. I don't know what the limitations are.
Okay. Oh, cool, because this is a great way to sort of get your initial project off the ground, and then